హలో ఇక్కదమ్మా so any doubt ma up to that, up to what coulombs? No, did you read it? Any doubt? Okay, so next one is page number 15, force between the multiple charges, right? Yes or no? Okay, so according to Coulomb's law, what is the force value? Coulomb stated that the force value is directly proportional to the Q1 and Q2 product of the two charges and inversely proportional to the square of the distance between the two charges. By combining both, we will be able to get with the proportionality constant K into Q1 Q2 divided by R square, and K value can be replaced by 1 by 4 pi epsilon naught Q1 Q2 divided by R square. This is the force between the two charges, right? Yes or no? Remember this value. So F equivalent to 1 by 4 pi epsilon naught Q1 Q2 divided by R square. Now what we are going to see is force between the multiple charges. When you are having multiple charges, what does mean by multiple? Only two charges. Now the question arises, when it is multiple charges, what will happen? Multiple charges means what? What does it mean? Multiple charges? Many. Means more than two. When you are having, anyway we know that force exists between the two charges only, and when you are having more than two charges, what about the force? What is the amount of the force exist between the charges? This is what we are going to find. Okay, so this multiple charges, they can ask another name, collection of point charges. Just write down now, collection of point charges, or this theorem, superposition theorem. Superposition theorem. They can ask in other names also for collection of points, or so. Yes, all mean the same. Yes, all mean same, but here it is given like force between the multiple charges, right? Yes or no? So when they are asking the collection of point charges, that is also more than two charges are present, and apply the superposition theorem, that also the same question only. Okay, so these two are other names. Okay, so if one charge here Q1 is existing and another charge Q2 is there, and the distance between the two, if I am taking as R12, R, that is distance between 1 and 2, so R12, then we know the force F equivalent to 1 by 4 pi epsilon naught Q1 Q2 divided by R12 square. For example, I am having another charge here Q3, which also acts on Q1. So any one charge I am taking which is ideal, and here I am taking the Q1 as the ideal one, which is the source charge, and other charges Q2, Q3, Q4, Q5, whatever the other charges, they just experience a force on Q1. Getting ma? So Q2 on Q1, Q3 on Q1, and Q4 on Q1. So what we are taking one charge as the initial origin point, on origin charge, which is Q1. All the other charges acts on Q1, because you need one charge which other values, if you are finding, means electric field and other things and all, we can go for test point. But F means force, means it always exists between the two charges only. So one charge I am taking as the ideal one, which is Q1, and other charges starts acting on Q1. Getting ma? See, one charge, force exists between the two charges, right? Yes or no? So one charge I am taking which is Q1. For example, I kept Q1 here as it is. Here I am having the Q1, will go according to Q1 I am having here, and Q2 I am having here. There will be a force between the two charges. So Q2 will act on Q1, force acting on Q1 due to the Q2. Well, how we will say? Force on 1 due to 2, right? So one force is started acting now. Now I am having another charge Q3, and this also acts on Q1. I am considering that Q3 also not on Q2. Same charge I am taking on which all the other charges induces the force. I can find the another force Q3 on Q2 also. But what I am taking only one charge, that is Q1. On Q1, what are all the effect of other charge and what are all the force acts due to the other charges? Sure, now you are getting? Which one? The distance between these two is R12. Distance. I am taking about the distance only, not the unit vector. R21 is the unit vector. When you are finding, for example, if I am writing the force on 1, 2, how you will write? K into Q1, Q2 divided by R12 square into R21 cap. Am I correct now? Yes, pa? So this is unit vector. When you are indicating the unit vector, there you have to write R21 cap. Sure? Here I am giving only the distance, right? Means scalar quantity. Distance, that is between 1 and 2, so R12. Getting, pa? Getting or not? Now I am finding the force between the 3 and 1. So force acts on Q1 due to 3. So it will be like this, right? F1, 3 vector, and the distance between the 3 is R13. Why I am taking everywhere R1 as a common one, initial one? Because I am finding the force on Q1. So which charge you are taking on which all the other forces are acting, you are going to calculate. So taking the distance with respect to 1, here R12, here R13. If I am having another charge Q4, then the force acts on Q1 is F14 vector. The distance is taken R14. Clear, ma? So whatever the number of charges present, which is initial first na endha charge vacha Q1 da vacha. So Q1 is the first charge, and I am keeping Q2. Then I am finding the force due to Q2. What the Q1 experiences. Q1 experiences the force due to Q2 F12. Then I am keeping the another charge Q3. Q3 also starts acting on Q1 because I am finding only on the Q1 force acting on Q1. All the other cases you can take some other charges also, but here what we are explaining is on Q1 what are all the forces acting. Q1 experiences the number of forces what Q1 experiences. This is what we are going to find. Getting, pa? It doesn't mean that Q3 will not act Q2, Q4 will not act on Q2. Yes, there will be some forces. But what we are finding is what are all the forces acting on Q1. Q1 I took as the ideal charge. Clear? Okay. So now the distance between the 2 and 1 with respect to that we wrote the equation. Tell me for 3 and 1, 4 and 1 means value of F13 vector and F14 vector. F13 vector will be equivalent to yes, pa. R12, no, it will not come like that. It actually here from the origin point they are taking all the directional vector also towards the Q1, right? See, directional vector, they have given the direction, no? Directional. See here, they are taking from 3 to 1 only. Yes, ma? See the arrow mark? 3 to 1 only it is, right? So, but they have written R13. It will not come like that. R21 only will come. Okay. Because it's a directional vector. See the direction? It is starting from 3 and ends at Q1. So, it will be from R31 only. Okay, ma? It is given here wrong. As unit vector will not hold any much value, as it is equivalent to 1, they don't bother about much at last. Okay. But you can write in the same way. This is only the correct way. Here if you are writing 1, 2, here you have to write 2, 1 only. Because the direction if I want to see the force direction, from which direction? From 2 to it is starting and it goes towards the 1. So it starts from 2, ends at 1. So we have to write R21 only. Okay, pa? Okay, ma. Tell me the value of F13 then. That is K into Q1, Q3. R31 cap, right? It starts from 3 and ends at 1. R31 cap. Getting, ma? How to write? So similarly, next one. If I take 3 charges, here I took 3 charges, right? Q1, Q2, Q3, Q4. On Q1 due to Q2, on Q1 due to Q3, on Q1 due to 4. So what is the value of that one will be? F14 vector is equivalent to, this is, first letter is giving on. Second one is due to what, right? This is what the way we follow. Yes or no? So on charge Q1 due to the charge 4, Q4. So what is the value? K into Q1, Q4 divided by R14 square into R41 cap. Am I correct? Okay. So if you want to find out the net force acting on this one, how many forces are acting there? Tell me on Q1 how many forces are acting? 3 forces, right? So according to, here only the theorem comes, according to superposition theorem. This is what superposition theorem. According to superposition theorem, the net force acting on the charge Q1 can be given as the addition of individual charges. Addition of all the individual charges. So F net is equivalent to F12 vector plus F13 vector plus F14 vector. Clear, pa? According to superposition theorem, the net charge, the net force acting on charge Q1. Net force acting on the charge Q1. This is vector now. You are able to follow. This one is vector. Okay. Force is a vector quantity, right? Yes. F net vector is equivalent to F12 vector, F13 vector plus F14 vector. Not clear? This part? So the net force acting on the charge Q1 is F net vector is equivalent to F12 vector plus F13 vector plus F14 vector. Is this clear now? Tell me, substitute the values. Substitute all the other values, F12, F13 and F14. Substituted, pa? So what is the value you are getting? First value is K, Q1, Q2 divided by R. Q3, right? Q1, Q3. Very good. Okay, so which is common here? Can we say some common terms? What are all the common things here? Q1, Q2, K and Q1. Very good. So K is a common factor which we know that is proportionality constant. So on which you are taking, that charge comes in all the other forces, right? Here also Q1 is there, Q1 is there, Q1 is there. So Q1 is a common charge on which all the other forces are acting. So we can take K into Q1 as a common one. So what are all the remaining things, ma? Q2 divided by R12 square into R21 cap plus Q3 divided by R13 square into R31 cap plus Q4 divided by R14 square into R41 cap. Am I correct? Just take the common terms, K into Q1 as a common. So Q2 by R12, Q3 by R13, Q4 divided by R14 the whole square. So here I kept how many charges, ma? Q1 is a common charge and 3 charges, Q2, Q3, Q4 near around the Q1. If n amount of charges are present, it is countless. We have more amount of the charges which is coming closer to the charge Q1. Then what will be there? Q2, Q3, Q4, Q5, Q6, Q7, Q8 and goes on up to Qn. Am I correct? So for multiple charges, if it is multiple charges, means for n amount of charges, how we can rewrite the equation for n charges? For n charges, how to rewrite this equation, ma? F net will be equivalent to K into Q1 which is common, Q2 by R12 square into R21 cap plus Q3 divided by R13 square into R31 cap goes on up to Qn divided by R1n square into Rn1 cap. Am I correct? Yes, pa? So here 2, 3, 4, 5, 6 and goes on up to which value? For n charges up to n. So Qn divided by distance between the 1 and the nth charge R1n square and the unit vector is Rn1 cap. Am I correct? So this one, if it can we write in terms of summation this equation? How to rewrite this equation? K into Q1. What is this symbol, ma? No. This is epsilon. Summation. Yes, what we use? Summation part, right? Yes or no? Summation which I varies from 2 to n q I divided by r. Just note down, ma. I value I am replacing, okay? I 2 to r 1I square into r I 1 cap. Shall I rewrite like that? Substitute I equivalent to 2. What is the value we will get? I is an integer which varies from 2 to n. I am taking the summation, right? Any value if you want to give in terms of summation, we use, remember the 11th standard summation part? Vector summation. Listen now, how to rewrite? Sum of many other terms, ai, where I varies from 2 to 5 means, substitute I equivalent to 2, what you will get? A2, A3, A4, up to what? When I varies up to 5, that means A5. We have to add the values which starts from 2 and ends at 5. So A2 plus A3 plus A4 plus A5. This is the limit of the summation part. Okay. So if I am starting from 2, what is the first value I will get? Replace I by 2. What you will get? 2I, Q2, right? No. R12. 1 is there. R12 square into R21 cap. Shall we get the first term? Okay, because I is an integer which I am using to add up to what? Up to which term I have to? Up to n term. Where you have to start? You have to start from 2. Getting pa? Now if I am substituting I equivalent to 3, what is the term you will get? I equivalent, I is a variable, right? I varies from 2 to n. R31 cap. Second term we are getting. Sure, this symbol is sum of. So you have to substitute I value, then add all the values. That is what this notification. Clear, ma? This is the simplest form. As I am adding all the values, here this summation gives you in short in a short indication that we have to add the terms and you have to replace the I value from 2 to n. 2, 3, 4, 5, 6, 7, 8 and goes up to n values. This is the limit. This is known as the limit. I equivalent to 2 to n means it starts from 2 and ends at n. Sure, pa? Substitute I equivalent to n. What you will get? Yes. You are getting the terms? As in between we are having a summation. What is the symbol we are using? Sum of. This indicates sum of. Sure, pa? Any doubt up to this? Why I didn't start from I equivalent to 1? Because I equivalent to 1, if I am substituting, charge Q1 is a common one, which is not included in the summation part. That's why I didn't start from I equivalent to 1. On which you are finding, that will not come inside the summation part. That will be in common term. Okay? Any doubts? So this is what superposition theorem. Superposition theorem is nothing but the net charge acting on the charge Q1 is equivalent to K into Q1 sum of, here if I am starting from 1, start from 2 to n Qi divided by R1i square into Ri1 cap. See, here also 1 is there. Distance between 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6, 1 and 7 and up to 1 to n. And here unit vector from n to 1. Okay, sure? Any doubts, pa? This you can write in the same way, ma. It is sure that unit vector will come from the I to 1 only. Just copy it. Copy it carefully, okay, these terms. See, can you see the figure 1.8, 1.8 figure B, and below that they have given one line. Can you see system of 3 charges and multiple charges? So this is the word also we have to remember. System of multiple charges they can ask, system of charges they can ask. So from that even we get another headings. The coming heading may be like that, system of point charges, system of also what it indicates, collection, more than 2 charges. Okay, pa? Okay. Copy this one. Okay. Tell me one thing. If I am having 2 vector, how to find the resultant vector? The figure B indicates the same only, how to find the resultant vector between the 2 vectors. This is the first vector, which is A vector, and another vector I am having which is B vector. What is the resultant vector? How to find the resultant vector? C vector, where it comes, C comes. Resultant vector, R vector or C vector is like this, right? R vector or C vector, right? Yes or no, ma? R vector is the resultant vector. What is the law we follow? Triangle law or parallelogram law. Remember, To find the net resultant vector, we have to take the resultant vector, that is which exists between the two vectors, which gives you the resultant between the two vectors. And here on Q1, if you see the forces, how many forces we are having? 3 forces acts on Q1, right? Yes or no? This is charge Q1 and this is the way we took F12 vector, and this is F13 vector, and this is F14 vector. How to find the resultant vector then? What we have to do? Find the resultant between F12 and 3. You will get one vector, right? Yes or no? And find the resultant between the F13 and 14. You will get another vector. So this is first resultant vector R1. This is second resultant vector R2. Now what we have to do? Again find the resultant between FR1 and FR2. That is nothing but in this case F13 vector is the final resultant vector. Getting for? See, any two vectors whenever you are drawing, this is in this case it comes like this. All the other values, whenever we are doing the example sums, you will come to know. Find the resultant between two vectors, these two, R1, and find the resultant between these two, which is R2, FR2. Then find the net resultant vector between the R2 and R1. In this case, it is acting along the same direction, which is F13. So F13 vector I can take as a final resultant vector, right? See, this is the two vectors, then this is the resultant vector. Am I correct? So here also the same thing, F13 vector acts as a final resultant vector. Any doubts, ma? So whenever you are doing the problems, what you have to do? Find the forces, F12 or F13 or F14, whatever the resultant forces, just find out that one and go for the vector addition method. And while doing the vector addition method, we should remember what is the resultant force. What is the resultant force between the two vectors, ma? Just make a note very carefully. This is very, very important. Resultant vector between the vectors. Between the vectors A vector and B vector is given by, given by modulus of resultant vector. What is the formula, ma? Okay, write down. Okay, root of A square plus B square plus 2AB cos theta, where theta is the angle between A vector and B vector. Okay, this is A vector and this is B vector. This is from 11th month, and theta is the angle between the two vector, and the resultant R vector is given by root of A square plus B square plus 2AB cos theta. Sure? Noted? No doubt. So this is the value we'll be keep on using. Okay, while doing the sums you will be needing this formula. So modulus of R vector is equivalent to root of A square plus B square plus 2AB cos theta. Angle between A vector and B vector. Okay, tell me for this one. This is A vector which is of phi I cap, and this is B vector which is equivalent to 9j cap. What is the resultant vector? How you will find the resultant? is theta value? Yes, what is the angle between the two? Good. Because here it is given I cap, right? I cap is acting on which direction? Plus x. According to coordinate system, what are all the values now? Plus I cap means plus x. Minus I cap means minus I cap. Plus j cap means y direction. Minus j cap means minus y direction. Remember this one? Okay. If here they have given plus I cap and plus j cap, that means it is acting along, one vector is acting along the plus x direction, another vector is acting along the plus y direction. The angle between two is 90 degree. So what is theta value in this case is 90 degree, right? Yes, pa? So what is cos 90? Cos 90. Cos 0 is 1. Cos 90 is equivalent to 0. Okay. No? Am I wrong? Cos 90? 0. Okay. Okay, ma? So cos 90 is 0. So if cos 90 is 0, what you will get? 25 plus 81. Only that is my resultant vector. 86 root 106. Sure, pa? How to find? If it is with an angle, if it is making 30 degree or 45 degree or 60 degree, then you have to substitute the angle here. If they have given I and j cap, we should know the coordinate system. I cap indicates the plus x, j cap indicates the plus y. Sure? Okay. So it is clear how to find the resultant vector. Just make a note, take an example and make a note. What is this one? Cartesian coordinate system. What is this one is known as? Cartesian coordinate system. These are all in 11th. Okay, ma. So next one is electric field. Yes, just check out the next heading, electric field. Am I correct? Okay. Electric field. What is meant by field, pa? Field. Area. Can we say area? Area around it? Field is nothing but the area around the charge. Here the electric field indicates that whatever the where up to which you can feel the forces. For example, here I kept the charge Q. Q I kept here. Okay, capital Q, which is source charge, I kept here. I am taking another charge, test charge, which is very less comparing to the source charge Q, and I am bringing it away from the infinity distance closer to the charge Q1. Whenever I am bringing the charge Q dash from infinity to closer, when I kept here the charge Q dash, it doesn't feel any force between the two. I don't feel any force. Okay, then I am moving. Here I brought the charge Q dash, I didn't feel any force. And I am taking closer to the charge Q. Here I started feeling either an attractive force or repulsive force. So up to this distance I am able to feel the force, and away from that area I don't feel any forces. Same like magnet. Whenever you are bringing one magnet you kept ideally in your hand, you are not moving it. Another magnet you are bringing from the faraway distance. You are not feeling the force between the two magnets up to a particular distance. When you are bringing it more closer to the initial magnet, then you start feeling either an attractive force or repulsive force. Yes? So up to that distance where it experiences the force, that is known as the electric field of the source charge Q. Shall I say like that? So when it is kept at the infinity distance, there is no any force of attraction or force of repulsion. I started moving the test charge. Why I call that as a test charge? By using that only I am testing where it experiences the force, right? And this is called the source charge and this is known as the test charge. So I am bringing the test charge closer to the source charge. I kept at a point, any point. P I kept at the point P, I don't feel any force. Then again moving the test charge, I came closer to the Q point, then also I didn't feel any force. When I am bringing closer to the point R, then I start experiencing the force of attraction or force of repulsion. So up to which the distance from the source charge Q, I am experiencing the force of attraction or force of repulsion. That is known as the electric field of the source charge Q. Is this clear? What is electric field? In the ஒரு particular distance வரைக்கும் தான் நம்மளால என்ன பண்ண முடியுதுமா force feel பண்ண முடியுது. Up to this distance I am able to feel the force. When it is far away from the source charge, I don't feel any force. Here F equivalent to 0. Here also F equivalent to 0. Here also F equivalent to 0. So we cannot say the electric field is existing at this point from Q. It is existing up to which point? Up to the R distance I am able to feel the electric field, the presence of the source charge Q. So the presence of the source charge Q, up to which distance it is existing, that area, that field is known as the electric field of the source charge Q. Sure? It can feel the force, either an attractive force or repulsive force. It is not that it should be always attractive or always repulsive. Any force up to which distance it experiences the Coulomb's force is known as the electric field. Initially when Coulomb did the experiment, he didn't mean to say the electric field of the charge. He just stated that force was existing between the two charges. But later on when Faraday comes into the play, Faraday he started doing the research and all. He found that it is not that force will always exist between the two charges when it is kept far away from the source charge. Test charge, when it is kept far away from the source charge, it will not feel any it will not experience any force. Up to particular distance when it is moved, then only it experiences the force, Coulomb's force it experiences. But the force may be attractive or repulsive. But up to particular distance, it experiences the force, that is known as the electric field. This is what Faraday stated. Sure, pa? Any doubt? So up to the particular distance around the charge, you may start feeling the attractive force or repulsive force. That area is known as the electric field of the source charge Q. Whether this field depends on any other parameter? No. It depends only on the source charge. Source charge எந்த அளவுக்கு அதிகமா இருக்கோ அந்த அளவுக்கு எலக்ட்ரிக் ஃபீல்டோட வேல்யூ அதிகமா இருக்கும். source charge கம்மியா இருந்ததுன்னா எலக்ட்ரிக் ஃபீல்டோட வேல்யூ எப்படி இருக்கும்? கம்மியா இருக்கும். புரியுதமா? புரியுதா? So the electric field depends only on the source charge. நீ எடுத்துட்டு வராம போ, என்கிட்ட வராம போ, என்ன வேணா பண்ணு. I don't bother about the other charges near around me. I am here and I exist my field strength around any particular area around me, and that field is known as the electric field of the source charge Q. Clear? So what is the force? If I am keeping the test charge and I am bringing the test charge, what is the force it experiences at this point? If I am taking, this is the distance, F equivalent to K into capital Q into test charge Q dash divided by R square. Shall I write like that? What is the charge I got closer? Q dash. What is the source charge? Capital Q. What is the distance it experiences the force? R. So how we can say K into capital Q into Q dash divided by R square is the force of attraction or force of repulsion. If both are positive or both are negative, repulsive force. And they are unlike charges, attractive force. Okay ma? Then what is the value of F then? K into capital Q into Q dash divided by R square. Yes, So what is electric field is force per unit charge, force per test charge. So if I am bringing q dash to the denominator or divide the equation by q dash, what you will get? Divide both the sides by q dash or bring this q dash to the denominator. What you will get? Very good. Kq divided by r square. So what is the electric field value? K into capital Q divided by r square. Is it depends on the test charge or source charge? It depends only on source charge. It nowhere depends on the test charge. Okay. So what is E value, ma? Finally, how we can rewrite the equation of electric field? Electric field is given by capital E is equal to K into Q divided by r square. In terms of vector, if you want to write, you can write r cap. R cap is the unit vector. Sure? Okay, just copy it. Is this concept clear? What is electric field? Okay. So how to define the electric field? This electric field can be given in two values. Just remember this one throughout. E vector is equivalent to F vector divided by Q, or the E vector is equivalent to 1 by 4 pi epsilon naught capital Q divided by r square. See, this is the source charge kept to Q, and I am finding the electric field at the point P, and the distance between the two is known as r. Then E vector can be given as 1 by 4 pi epsilon naught capital Q divided by r square into r cap, where r is the distance between the charge and the test point P. Clear, pa? So two vectors. What are all the two values for E vector? E is equivalent to F vector divided by Q vector, and this is test charge or unit charge. Test charge or unit charge. This capital Q is your source charge. And the electric field depends only on the source charge, not on the test charge. Sure? Which one, ma? Okay, today evening I will send you the photograph. Actually, the boy who is coming here, no, he is writing in the same manner. I asked him to write the same. I'll send you that photograph. What you do is you start writing in the same manner. Don't write at the back, ma. You just separate a small copy, 80 pages, small copy. You just take the formula note and you start writing from the initial all the chapters, the formula note. Okay. And I asked him to do the same thing. Thank God you asked. I forgot to say. One note for formulas. I'll send you the photographs today, and you copy the same thing up to this electric field. I will send you the photographs. You start following, because how to write, this is what you may get from that copy, and later on you just start doing the same thing. Okay, ma? Sure. I'll send you by today evening. Today evening he will be coming for offline classes. I'll take the photograph and I'll send you. And don't write on the back side, ma, because obvious it will not get, it will be keep on coming, no. So you put a separate copy, formula notebook, 80 pages, small pages, small notebook, that is enough. Okay, so E vector is F vector divided by Q vector, and E is equal to 1 by 4 pi epsilon naught Q divided by R square. So this is what they have given in the book also. Can you see in the book? F is equivalent to 1 by 4 pi epsilon naught Q divided by R square into R cap, and FR is equivalent to Q into ER. What is the relation? This is what we did here, right? E is equivalent to F divided by Q means what happens to the F? F equivalent to Q into E. Yes? Okay. And what are all the types of charges we are having? Types of charges. Types. Types of charges. Simple. Positive charge and negative charge. Don't forget that one. What are all the types of charges we are having? Positive charge and negative charge, right? So this electric field, how it exists for positive charge and negative charge. See, if it is a positive charge, I keep a positive charge, and the electric field is always existing from the charge to infinity distance. So the electric field lines are represented in that way, that arrow marks starts from the charge and it goes out from the source. Outward direction we have to draw the electric field lines. Okay. Electric field, how to represent the electric field? By using the field lines we can represent the electric field. If the lines are moving from the charge, that means it is a positive charge. This is the way to represent the electric field lines. For positive charge, the electric field lines are, that doesn't mean, actually this is more whenever we are giving closer to the charge, the electric field is more. Why? Because E is inversely proportional to 1 by R square. Yes or no? Similar way like force, when you are moving away from the charge, force value reduced. When you move away from this point charge, the electric field density also reduced, right? Because it is inversely proportional to R square. Getting that point? So this is the point charge which is having more electric field density closer to the charge, and when you move away from the point charge, it starts reducing. But the direction of the electric field lines are represented like it starts from the positive charge and ends at infinity for positive charge. If it is a negative charge, the charge which you have taken is negative, then electric field line starts from infinity and ends at the charge. So this arrow mark indicates whether it is a positive charge or it is a negative charge. If the arrow marks are towards the charge, what does it mean? The charge value which I took is negative. Away from the charge means what is the charge? Positive. Okay. And how they are related? E and R inversely proportional to each other. R increases, what happens to the electric field? It decreases. Okay. Make a note. Noted, Pap? Okay, so the first line, see here also write down this one, the point, page number 18. Here they give you some important remarks may be made here, like they have given 4 points. Can you see? So those 4 points they can ask, write the importance or aspects of electric field. That is separate 3 mark question. 2 or 3 marks they can ask you. So what is the question is? Important aspects of electric field. Okay. And what is the SI unit? Can you say the SI unit? What is the SI unit of force? Newton. SI unit of charge? Coulomb. So what is the SI unit of electric field? Newton Coulomb to the power minus 1. Okay. So make a note now. SI unit is Newton per Coulomb or Newton Coulomb to the power minus 1. And draw this diagrams also. If it is positive charge and if it is a negative charge. Completed? Okay. If it is a pair of charge, later on, next topic will come that only, dipole. If I am having a pair of charge, one is positive, another one is negative, then how it experiences, how to draw the electric field lines? How to draw the, it starts from positive, ends at negative. Okay, so it will be like this. Getting how to draw? See, it starts from positive charge. If you go for a positive charge, away from the charge. If you go for a negative charge, towards the charge. So arrow marks are drawn, started from the positive charge and ends at the negative charge. Okay. Just now, this is known as dipole. What does mean by di? Di. What does mean by di? 2. Okay. Tri means 3, di means 2. So 2 poles are kept. One is positive, another one is negative. So this is known as a dipole. First case positive charge, next case negative charge, third case dipole. Then fourth one, between the parallel plate capacitor or parallel plates. Fourth one is between parallel plates. Between parallel plates. One is positively charged plate, another one is negatively charged plate. Then the electric field exists. It starts from positive, ends at negative, right? Yes or no, ma? Always electric field line starts from the positive and ends at the negative. Okay. So here only the electric field is existing. Left side of the plate and right side of the plate, E is equivalent to 0. This is very important case. Note down. Between the parallel plates, the electric field exists between the plates only. Left side and right side means out of this area, then electric field is equivalent to 0. We have derivation for all these things. Okay.